Okay, hello everyone. So today we're going to talk about friction or the frictional forces. It is also an important topic in a regular physics study. I believe you all have some idea about what friction means. It is a resistance that when you try to move something, when an object is sliding against a surface, you feel this resistance. You have to apply force. You need to do work in order to move something. So this resistive force that is acting against the motion is called a frictional force. So in this discussion, let's talk about what creates friction, what is the reasons behind friction, how to represent it using a proper diagram, how to make calculations. So those are the things that we will talk about. So friction, let's take a simple example. Let's say this is a horizontal flow, and here you have some heavy drawer, right? And let's say this is your bedroom, and you want to move this drawer from one side to the other, right? So you're applying a force like this. You're pushing it, or you're pulling it. So you are applying a force, and you will definitely feel a resistance. This thing is not easy to move. So the friction is always between two surfaces. When you try to move something, when an object is sliding against another surface, right, you always have to have two surfaces. So between the two surfaces, that means right here, between the floor and the bottom of this drawer, there is a resistive force pointing in the other direction. So this is friction. One important thing about friction is always against the motion. If you try to move it to the right, the friction will be towards left. And then you switch the directions and you try to go to the left, the friction will immediately, automatically will switch direction. So friction or the frictional forces are always against the motion, right? Okay, so in very simple terms, this is what friction is. And in diagrams, let's say we represent this drawer using a box like this. So you apply the force. So we typically use F to indicate force, and friction is against you. Friction also starts with the word starts with letter F. So to avoid confusions, we usually put FR to indicate friction, but there are different variations. Sometimes we'll use FS, sometimes we use FK. This is all terms that we use to indicate friction. So I will talk about this in a little bit. Alright, so basically friction is a force that's against the motion. Now what creates friction and what decide how big it's gonna be, how big or small? If we take a fine microscopic view of these two surfaces that are in contact, like right here, right, if you magnify this, friction always occurs between two surfaces that are in contact with each other. So if you magnify this, even if it is a smooth surface, right, so this is the bottom of the drawer, we will see that all sort of this unevenness or little bumps like this. So no matter how much you try to make it even, like you can have like a very polished surface, there's always this microscopic unevenness that is always there. And the flow is also, even if it is a very smooth surface, there could be little microscopic let it be, you know what I'm talking about, right? There'll be little differences like this. So so it is due to on the surface, if you go to this atomic level, there's molecules like this, and there are molecules over here. These things have molecular attractions between each other. So the top surface will have some attraction towards the bottom surface. So those molecular bonds, now you try to pull it this way, these attractions are working against you. In order to move this, you need to break these molecular attractions. That's when you can move this thing, right? So, and when you break few, the new attractions can occur. So the friction is gonna be there no matter what. You will be pulling it slowly, you will be pulling it faster, but some amount of friction is always going to be there. Friction can change when you start moving things, so we'll come to that in a little bit, but it's not going to disappear. You can do so many things to decrease friction. You can apply, you can make it smoother, the surfaces. You can apply some sort of what you call like oil or grease kind of materials to decrease friction, but it's very hard to completely get rid of that. So the reason what creates friction is this little molecular attractions. Alright, so talk about two things, right? Firstly, it's against the motion and what creates friction. Okay, another important thing is that there's two types of friction. Okay, not just one type of friction, but two types. So let's see what those two are. Number 2, types of friction. Two main types: static friction and kinetic friction. So as the name suggests, static friction is the friction that you can feel in objects when they are stationary, when they are not moving. You try to move something, you feel a resistance, the object is still stationary, it's not moving. That friction, that resistance is called static friction. Now when the object, like let's say you're pushing this drawer or you're pulling it and you manage to get it to move, now it's moving across the room, across the floor, still you have to apply some force to keep it going, because there is still some kind of resistance even though it's moving. That friction is called kinetic friction. So two types. So let's say static. When objects are stationary. Stationary, there's no space here, so I have to write it like this. When objects are stationary. Remember, friction is always between two surfaces, right? You can't just say the friction of the table or friction of the drawer. You always have to use the word the friction between the drawer and the floor. The friction between one object and the other, the friction between the surface 1 and surface 2. So there's always, you have to have two surfaces that are try to move relative to each other. So that's the way to, correctly explain friction. So static friction is when objects are not moving relative to each other, and kinetic friction is when things are moving. Now there is a difference between the amount of friction you feel. In general, right, in general, static friction is bigger than kinetic friction. We normally use letter symbols. Static friction normally denoted by Fs. S stands for static. It's normally bigger than Fk. Alright, so that means when things are stationary, when things are not moving, they have much more friction between the surface they are sitting on. But if you able to get it moving, if you able to create some movement, then the friction drops a little bit. It becomes a little more easier to move something once it is in motion. So kinetic friction is normally less than static friction. Now we can explain this using, again, going back to these molecular bonds, right? Let's say here's the bottom of the drawer and here's the floor. So if it is stationary, there's so many molecular bonds between them. You have to break all of these in order to get this moving. But once it's moving, this is static. Oops. Once it's moving, because of the motion, sometimes there is not enough time for these bonds to build up, or because of the unevenness, there will be there will be bigger gaps between these molecules, so the bonds won't be that stronger. So once things are moving, it's easy to keep going. Kinetic friction gonna be little less than static friction. Okay, so these are two main differences. These are the two main frictional forces we're gonna discuss, and there are differences between them, and this is how it is. Static is bigger than kinetic most of the time. Alright. Okay, so let's talk about how to represent friction in a force diagram. So normally, or most of the time, when it comes to force diagrams, we use a box to represent the object. It's easy to draw, easy to understand, simple. It could be a drawer you are trying to move across the living room, but it could be a couch, it could be a refrigerator. We just draw a box, right? That's kind of standard practice. So again, let's see. So here's the drawer or the box, and you are applying a force like this. Friction is against you. So we normally draw it from the center of the bottom surface and pointing in the opposite direction, right, like this. And we can say friction. Now if this is stationary, so let's think about a stationary situation or a static example. We can say Fs. So and it has to be between the two surfaces. Another important force we can mark on this diagram is the weight, right? Friction between two surfaces determined by a couple of things. Number one is the weight of the object. which is mg, right? So bigger the object, more mass it has, more weight it creates. So the weight is pushing down on the bottom surface, right? So here's the weight. So the weight is pressing this object against the surface that it tries to slide on, right? So the more weight it has, more friction it will create. But when it comes to friction equations, when it comes to friction calculations, we really don't use the term mg. We replace it with something else. So now when the weight of the object is acting on this bottom surface, in this case this is the flow, right? When this box is pushing against the flow is pushing back. It comes from Newton's third law. Every action has a reaction, equal and opposite reaction. So weight is pushing down, flow is pushing back. We call this the normal force. We denote it with Fn. Fn stands for normal force. The term normal here to indicate that it's a perpendicular force. Perpendicular, right? Normal force is always perpendicular. This pushing back force, this reaction force, is always perpendicular to the surface. Not it. Now in this diagram it looks like it's perpendicular to the box as well, but it's actually perpendicular to this surface right here, right? Perpendicular to the surface. Okay, so normal force. Normal force sometimes, normally we denote it by Fn, but sometimes we just say N, just the normal force, or sometimes we say R, reaction force. They all mean the same thing. So one thing that determines friction is, I started with saying weight of the object, but actually weight of the object leads to normal force. So the better term is friction is determined by the normal force. So that's first thing. Number two, determines by the type of the surfaces. Actually, it's better to say chemical properties, chemical and physical properties. Chemical and physical properties means how strong these attractions are between the two surfaces. So it comes from both surfaces, not just one, right? One surface is kind of attached to the second surface. So how strong these chemical bonds between the two surfaces, and how even, how smooth the two surfaces that are sliding against each other. That comes from physical properties. If there's so many little bumps, sometimes they can go into each other, inside each other, so that increases the bonds between them, makes them stronger. At the same time, it can create more separation between us, so it's really hard to have a clear picture of this when it comes to the microscopic level. But definitely these are certain things that that determine friction between two things that are sliding against each other, right? So to denote all these surface properties, we use a term called mu. This little U-like thing with a longer one side. So it's a Greek letter pronounced as mu, mu. This is called the coefficient of friction. So this coefficient or mu comes from, it's just a number. It comes from all these chemical, it summarizes all these chemical and physical properties between the two surfaces. So for an example, we can say mu between wood and plastic is 0.4, something like that. Let's say you're trying to push this plastic drawer, the drawer, let's say, assume that it has a plastic bottom. You're trying to push it against a wooden surface. This is the coefficient of friction is there, right, between these two surfaces. Now if you try to do the same thing, let's say instead of a wooden surface you have a carpeted surface, it might feel a little more resistive, right? Think about it, like you have this heavy drawer, you try to push it. Wooden surface, maybe you are able to manage. Carpeted surface will have more friction, will have more resistance. So the weight of the object didn't change. What changed was the surface properties. So that's what mu is about. It tells you how much friction between two given surfaces, right? So friction is determined by, once again, two things: the normal force and mu. And as before, mu has two types. If it's static, if it is not moving, we say it's the static coefficient of friction. So mu s, static coefficient of friction. If the object is moving, the friction decreases a little bit because the coefficient changes a little bit. So in moving cases we use mu k. Kinetic coefficient of friction. So these are a couple of things to keep in mind when we work on friction problems. Alright, so let's I'm gonna clear all this and then we'll work on a static friction example. Okay, so let's go back to another the static example one more time. So here's the flow, here's the drawer. Let's say the drawer has a mass m and you are trying to move it to the right. Now in the force diagram we know that we have a weight which is mg and the flow is pushing back F normal force, and we know that this Fn is equals to mg, right? The normal force is equals to the weight of the object. Now when you try to push it to the right, friction comes into the moment you apply force, right? Let's say you start slowly, you start with like 1 Newton. The friction comes into play and it creates this friction force Fs in the opposite direction. Friction is such a unique thing. As long as you don't apply any force, the friction won't be there. It doesn't exist. The moment you try to move it, the friction appears in the opposite direction. If you increase the force you are applying, the friction matches that. It increases automatically. So but it has a maximum limit. Once you go beyond that, then you are able to move it. So an important thing, right? Friction or static friction can increase from 0 to a maximum value. So in order to move something, you have to overcome this maximum friction, right? Okay, so let's say you apply, now here's the object, you apply 1 Newton. Friction will match that with 1 Newton. And you increase the force to 10 Newtons. If it is still not moving, that means friction is also 10 Newtons. Whatever you apply, friction can match that. Let's assume that the maximum friction can do is 15 Newtons. So even at 15 Newtons, this is what you apply, right? 15 Newtons. Friction can match that, 15 Newtons. So it's still at a static situation. It's still not moving, but it's about to move. Now if you can increase the force a little bit, let's say you make it 15.5 Newtons, friction has reached its upper limit. It's 15. So now you have a net force. You have a net force of what? 0.5 Newtons, which can move this object, which can create some little acceleration. So friction can, starting from 0, it can reach to a maximum. This maximum depends on the type of the two surfaces, right? That means the coefficient, and also the normal force that comes from how heavy the object is. So once up to that point, you are under static friction. Once it starts moving, it switches to kinetic friction, right? So how do we find the friction? Like, how do we know what the max friction is, or how do we know what's the friction at any given point? So let's say this is the applied force. Now if you want to move it, you need to figure out how much friction is there. Friction comes from Fs, comes from mu times Fn. This is this simple equation. This is the maximum static friction you can get. The normal force, or in other words, in this case, the weight of the object multiplied by coefficient of friction gives you the maximum possible static friction. It's important to remember that at lower values, see, this is not like a one constant number. Over here you apply a force, Fs is 1 Newtons. Over here your force becomes 10 Newtons, Fs is 10 Newtons. Over here you apply 15, Fs is 15. Now you apply 15.5, Fs is still 15, so you are able to overcome the friction and bring and move this object. So the better way to write this equation is Fs is less than or equals to mu times Fn. Fs can take any value from 0 to a maximum. The maximum it can be is mu times Fn, right? So in this case mu times Fn is 15. That's the maximum it can get, but Fs can start from 0, can any in between value as well. Okay, so if you want to move this, you need to apply at least this much force, and if you can apply little more than that, you can move the object with a little bit of an acceleration. So let's try an example. Let's put some numbers and see how this works. All right. Okay, so let's look at an example with numbers. So we're gonna go back to the same example where you have this drawer. For this case, let's assume that the drawer it's a wooden drawer, right, made out of wood, and the floor is also wood. So it's a piece of wood is sliding against wood, right? So we say wood on wood. So let's say this is a heavy drawer, which is 100, massive drawer, 100 kilograms, and you want to calculate how much force you need, how much force you need to push this across the wooden surface, right? So what information do we need? We need to calculate how much friction is there when you try to push this. That is always this Fs. You need to overcome this static friction in order to get it going, right? So we need to know how much force, what's the minimum force you have to have in order to get this going. So how do we do that? So we can use Fs equals mu s, static coefficient, times Fn. So mu s times Fn. What is Fn? In this case, we have the weight, which is mg. So what is mg? Is 100 times 9.81, which is 981 newtons. So the weight is 981 newtons. So the surface is pushing back with an equal and opposite force. So Fn is going to be 981 newtons. So mu s times 981. Alright, what is mu s? Now these are experimental values. In the PowerPoint, one of the slides will have a table of friction coefficients. In the exam, I will give it to you, or in the problem you will be able to figure it out. So in this case, I'm going to give you that mu s for wood against wood, wood on wood, is equals to 0.4. I'm taking this value from the table. And also remember, these friction coefficients, they don't have units, they're just numbers, right? So just the number. So Fs is 0.4 multiplied by 981 gives you, what is Fs? So take the calculator, multiply it by 0.4. So roughly like 240 or something. Let's see what it is. Huh, 392. Fs is 392.4 newtons. So the maximum friction you can expect is 392 newtons. So in order to move this thing, you have to have at least 392.4 newtons. If you have this, yes, you can overcome that static friction, right? So this is how you find the friction. The most important equation, the important part here is using this equation correctly. Okay? All right. Okay, so let's assume that you are able to apply this much force. Get help from somebody. Together, somehow you are able to apply more than 392.4. If you don't have 392, that much force, you are not able to move it, because friction going to match whatever force you apply up to 392.4. So if you can apply more than that, now the object is ready to move. So let's say you do apply 392.4, right? Let's say you apply 400. So here's the object. You apply 400 newtons. It's little more than what is needed. So what's going to happen? Now in this case, we know that this object now force is bigger than the max static friction. So that means it will move. That means we have to now switch to kinetic friction. For the rest of the problem, to understand what's going on when it is moving, we have to switch to kinetic friction. Okay, so if you think about the force diagram now, you have 400 newtons and you have some friction pushing back, which is Fk. Now this is moving, so we can't use Fs anymore, right? Because we were able to apply more than enough to overcome the static friction. Now the object is definitely moving, so we have to use a new friction, which is kinetic friction, the friction of moving things. Okay, so how do you find the kinetic friction? It's the same equation, Fk equals mu k times Fn. Now I'm going to go back to the data table and look for mu k for wood on wood. These are experimental values. You don't have to memorize these things. These things will be given in the exam if needed. So mu k is little less than mu s. Kinetic is little less than static. So the table gives me the value of 0.2. Alright, so 0.2 multiplied by Fn is 981, which we calculated before. So what is Fk? Half of that, half of 392 is 150, 180, something like that. 0.2 multiplied by 981 is 196. Okay, so you are applying 400, against you we have 196.2 newtons. So what happens here? What's the net force? What's the net force in this direction? It will be 400 minus 196.2, 203.8. This is the net force. Now what's going to happen? You have a net force acting on an object. Now once we do this, once we subtract the two forces, the applied force and the friction force, we don't need to worry about friction anymore because it's already taken care of, right? So this is the only force acting on the object. The object has a mass of 100 newtons. You don't have to worry about this mg and fn because they cancel out each other also. So the only unbalanced, only net force acting on this object is this 203. So what happens? It's going to accelerate because there is a net force. And what is that acceleration? We use F equals ma. 203.8, that's the net force. Mass is 100 times acceleration. So the acceleration is going to be, divide this by 100, 2.038 meters per second squared. Right? So once you overcome friction, once you overcome static friction, and if you still continue the force you are applying, the object is going to move and it's going to accelerate. So yep, so that's how it works, right? The moment you overcome static, the friction is going to get decreased a little bit because it's moving, it doesn't make too many molecular bonds, and it has momentum, it has inertia. All these things help with moving, so you feel less friction. What if you apply an equal amount of 392.4? So now you come to like a in-between state. It has almost overcome the static friction. It's about to move, it's ready to move. So you really can't say whether it's going to move it or not. It's kind of in-between state. but if you just give another slight push, it will start moving, the friction will drop, and if you do not reduce the force, you can accelerate, right? So for an example, in this kinetic case, this is the kinetic situation. Now you don't have to maintain 400, right? It's already moving, so all you have to do is, if only thing you need to do is just move this thing, as long as you match this 968. So instead of 400, you can just apply 196.2, or maybe a little more than that. Now you can move this thing easily, right? The difficult part is to overcome static. After that, it becomes a little easier. Okay, all right.